Alright, for example 5, a woman drags a box of 20 kg up a rough slope. The slope is at an 10 degrees to a horizontal to the coefficient of friction between the box and the slope is 0.45. The woman pulls the box using a rope held on an angle of 20 degrees above the slope and with a tension of 120 Newton. Find whether the force is large enough to clear a motion and if it is, find the acceleration. So I have draw a rough diagram for this pulling. So from here, right, we have the angle of this location is 20 degree, and we have the slope angle here, we have a 10 degree. So when you want to start to analyze a question in the mechanics, you may need to draw a diagram to reflect the context of the questions. So from this situation, it's still the same. We will resolve the forces to the vertical to the planes and parallel to the plane. So let us start to form a equation for that. So first, I remove the diagram first. Never mind, we keep the diagrams. So first, we may have R plus 120 psi 20 is equal to 200 cos 10. And from here, you will get R equal to 150 Newton. Okay, so once we form the perpendicular component, we may need to form the parallel components to the plane. So I will remove this part. So for the parallel net force equation, if you have any net force is not in the equilibrium, you may form a new equation 120 cos 20 minus 200 psi 10 and minus the mu r, the fractional force, and equal to 20a. And from here, you should be able to find that a equal to 0.393. Hopefully you can get that. This is for example 5, right? Alright, so if you have done example 5, we may proceed to example 6. Alright, so I will remove this part first. So as for example 6, for A box of mass 10 kg is pushed from the rest along a rough horizontal ground by an horizontal force of size 50 Newton for 3 seconds. The coefficient of friction is 0.45. Find the speed when it stopped being pushed. Right. So same things. Before you start, you should draw a diagram. Okay. You have 100 here, Newton, mg, and you have pulling force is 50, and opposite direction you have mu r. As you know that when the box or when the item is starting to move, the friction will be equal to the limiting friction. So we know that in the vertical component, r equal to 100 Newton. And we know that if we resolve to the horizontal, if the either in the movement, we have a 50 minus mu r is equal to 10a. So from that, we know a equal to 0.5 meter per second. Right? And from that, we will use v equal to u plus at because it's a constant acceleration, and you will get a 1.5 meter per second for the velocity. Right, so this one for part A. For this question, because we will assume that because the question mentioned that we start from rest, so the initial velocity will be equal to 0. This one for part A, question 6. Alright. Okay, for part B, the box then slows down because of the friction, and find the total distance the box has moved. So we know that S will be equal to ut plus half at squared. Okay, so S will be equal to S1, the initial distance will be equal to 0 plus half 0.5 times 3 square. Right. So at the beginning, before it slow down, you have a distance that travel 2.25 meter. Okay. After this 2.25 meter, the thing start to slowing down. Right. So we need to calculate the distance that travel by the second part of the distance. Right. So we may draw a new diagram for the items. Okay, the item is here, and here also still 100, but now you have a mu r at the beginning as a deceleration, right? So we can draw that force equation, r equal to 100 Newton, same things, and minus mu r equal to 10a, and a will be equal to negative 4.5 meter per second square. Right, so we have the deceleration now. Once you have the deceleration, you may proceed to calculate. Right, v square equal to u square plus 2as. Right, so that you have a 0 equal to 1.5 square plus 2 negative 4.5 s2. S2 is the second stage. So S2 will be equal to 0.25. So the total distance that travel, total distance will be equal to the initial first stage plus 0.25. So the total distance that travel is equal to 2.5 meter. Right. So this is the totals. The first stage plus the second stage. So that the total distance that you travel is 2.5 meter. Right, so this one for question 6, part B.